Let's try one more challenging problem, one more little more difficult problem here from the exercise, suggested problems. Let's try problem number 31. Number 31. From the suggested exercise. Suggested problems from the exercise number 31. What does it say? Use binomial series to expand the function as a power series. It's fourth root of 1 minus x. So step 1 is to write a 1 minus x to the power 4 as 1 minus x to the power 1/4. If you have to write it in the representation of binomial, you're going to write this as 1 plus negative x to the power 1/4 because we want to make it look like 1 plus x to the power k. So we want to have a plus sign. So that's the reason we want to write that as 1 plus negative x to the power 1/4. When you write this in binomial representation, when you write this as a binomial series representation, f of x equal to fourth root of 1 minus x, it is also equal to 1 minus negative x to the power 1 by 4, which can be written as sigma, n varying from 0 through infinity, n chosen out of 1/4, this is the symbol we use, times here in the problem, in the binomial series representation, we have x. Here we have negative x. So we are going to replace that with negative x to the power n. So we are going to expand in the next step. Now before we expand the terms, of course, we are going to get back to this step after we evaluate these coefficients. So the first one is going to be obtained by plugging in n equal to 0. So what is 1/4 0? That is 0 out of 1/4 of the things. So anytime you have 0 here, that value is equal to 1. Then the next 1/4 at 1. We are choosing 1 out of 1/4. So it is just 1/4. 1/4 here over 1 factorial. Then 1/4, 2. 2 chosen out of 1/4. So you start at 1/4 and start reducing 1/4 minus 1 over factorial 2. So it is 1/4 times negative 7, 1 minus 4, that is negative 3 over 4 over factorial 2. Factorial 2 is 2. So if you find the value, it is negative 3 over 16 divided by 2. So it is negative 3 over 32. So like that you can do more terms. If you have to do 1/4, 3 chosen out of 1/4. So start reducing, start at 1/4, start reducing one at a time. But how many factors you should have on top? As many factors as you see here. So here 3. Then don't forget the 3 factorial. If you reduce this, it's 1/4 minus 3/4. This will be negative 7/4 divided by factorial 3. Factorial 3 value is 6. So it is positive 21 divided by 64 times factorial 3. Factorial 3 is 6. So if you reduce, it's going to be 7 over 128. So you can continue like this. Substitute these values into 1. So we get f of x, which is 4th root of 1 minus x, which will be, if I go back to this step and write this in the expanded form, I'll have 1/4 at 0, x to the power 0, plus 1/4 at 1, x to the power 1, plus 1/4 at 2, x square. It goes on like that. So this will be 1. This will be 1/4 x. And 1/4 at 2 is negative 3 over 32. Oh, this is actually negative x to the power n. So it is negative x to the power 0, negative x to the power 1, negative x the whole square. So it goes on like that. So we are going to have a negative x in the parentheses. So the second term is going to have a negative sign here because we are multiplying by negative x to the power 1. The third, 1/4 at. So we have to do the last part, which is finding the radius of convergence. So for that, we are going to use the ratio test. But we also know that the binomial series converges when absolute x less than 1. This is what we stated in this step, absolute x less than 1. For the series 1 plus x to the power k, here the x is replaced by negative x. So the series converges when absolute negative x is less than 1 or when absolute x is less than 1. So the radius of convergence for this binomial series is equal to 1. So for the last problem, in this example, my video got disconnected, so I'm resuming it. So you have these steps here. So we first write down the binomial series representation of this with k, exponent k replaced by 1/4. This notation we expanded earlier. So we are going to explain each one of those terms there. So we are going to plug in from n equal to 0 here. So the first one will become 0 chosen out of 1/4, which is 1. 1 chosen out of 1/4, so it is 1/4 over factorial 1. Then 2 chosen out of 1/4, so you have to have 2 factors always, as many as the number that is shown below. Then we will have whatever that number is that goes in the denominator. So if you reduce that, it becomes negative 3 over 32. Then 1/4, 3. that will become mm, 7 over 128. So substituting these values into binomial series, keeping in mind we have negative x to the power n in the first step. So we have all of this step here. You can simplify these values if possible. Then after we write that as a series, we have to also write down the radius of convergence. It follows from the binomial series. Binomial series works when converges when absolute x less than 1. In this case, x is replaced by negative x here. So absolute negative x is less than 1 gives the convergence condition. That means absolute x less than 1, which tells us that radius of convergence is equal to 1. I hope these videos help.